Hi everyone, my name is Tommy. I'm a senior software developer at IBM. I'm mostly at the open technology team at IBM, mostly leading Kubeflow developments for our IBM research and IBM products. And today we're going to discuss some of the optimization we've done for Tekton because we're actually running Kubeflow Pipeline 2.0 with the Tekton backend and some of the challenges and benefits for why we want to use Tekton as a backend for Kubeflow pipelines. So before we jump into Kubeflow Pipeline 2.0, we want to summarize some of the benefit we see when we use Kubeflow Pipeline v1. So one of the reasons we picked Kubeflow pipelines as our pipeline orchestrations is because Kubeflow Pipeline provides a very useful user interface, a very good engine for scheduling multi-step ML workflows, a very awesome Python SDK for defining and manipulating pipelines and components. And because it has the Python SDK, all our data science users are able to use their notebook to interact with the system using the Python SDK. Because all those features are awesome, we really like to use the Kubeflow pipelines for our productions. But there was some challenge with the V1 designs, and we're going to discuss from now. One of the challenges it has is the machine learning metadata in KPV1. Although in KPV1 all the metadata syncing is asynchronous, and it will able to retrieve the metadata from our pipeline runs into MLMD servers. All those metadata, most of them are technically preliminary data, which we define right before we run the pipeline. It just precompiles when the pipeline is executed. We just point to where the artifact is produced. There's no way the pipeline itself know the metadata we record in MLMD is located, and it retrieve those information to use as part of the pipelines. And because if it's actually getting the MLMD metadata, showing the MLMD metadata from the pod itself, it's very sensitive on how the spec is defined between different backend like Argo or Tekton. And if when Argo has a spec change, it has to be aware how Argo store those metadata information in either annotation or environment variables. So when there's spec change, metadata writers, that's the V1 version of how it stores metadata, has to be rewritten in a way that is specific for the orchestration engines. And even with all this works, when we actually run TensorFlow extended pipelines, TensorFlow extended actually using the MLMD library itself to store metadata. So all those hardware we have done for the metadata writer is not technically integrated as part of the TensorFlow exchange pipelines. So we see like there's a big gap between the KPV1 metadata and TensorFlow extended pipeline metadata. And the second limitation we see is when we use Kubeflow Pipeline v1 is the pipeline spec is very specific for the backend engines. We all know like when KP pipeline kind of like created is mainly specific for running on Argo pipelines. And within our IBM organization, we do have like restriction, and we have like team that already running Tekton for their CI/CD. So we would love to run CI/CD and all the machine learning pipeline on top of Tektons. And one of the challenges we see when we integrate Tekton into Kubeflow pipeline is that because Kubeflow pipeline v1 is very specific for Argo CI YAMLs, all the stuff we want to integrate into Tekton has to be rewritten on both on the UI level, pipeline UI levels, SDK levels, and also all the backend caching metadata writer microservices. So it makes the code changes very messy when we integrate Tekton into Kubeflow Pipeline v1. And this is why we also discussed with the Google team and work towards Kubeflow Pipeline 2.0 to have a one solid code base for multiple backends. So when we kind of get into Kubeflow Pipeline 2.0, it has all the great feature from Kubeflow Pipeline 1.0 plus the additional feature from here. So you can actually order end-to-end ML workflow natively in Python now, able to customize ML components and leverage the ecosystem of other existing components from V1s. And you could still easily manage, track, and visualize pipeline definitions. And it's more natively with MLMD metadata now. And you could use compute resource like parallel task executions, and the caching mechanism is actually more mature and advanced in V2, where we will show later on how we could actually enhance our pipeline performance using Kubeflow Pipeline v2. And the most important part is Kubeflow pipeline V2 is actually maintained with a cross-platform pipelines, and it is able to pour those pipeline using a platform-neutral IAM YAML. So no matter what kind of backend you're going to integrate in the futures, you could use the same intermediate representation YAML that you produce with the SDK, and doesn't need to care about the underlying deployments. And this is very beneficial. Because the Google team already introduced a lot of usage and how to use Kubeflow Pipeline 2.0 and in last year's presentation. So now I'm mostly just going to dive into how Kubeflow Pipeline 2.0 is being implemented and on the technical detail how it's integrated between Argo and Tekton. So on a very high levels, right? Kubeflow Pipeline 2.0 is designed with this TensorFlow extended driver and publisher mechanisms. And what the driver is going to do, there's two parts. So one, whenever you actually create a pipeline, it actually represents as a DAG, a direct acyclic graph. And in the DAG drivers, there's two kinds of DAG driver. One is the root DAG driver, which represents the whole pipeline run itself. And whenever you create a loops or a sub-pipelines, there will be a sub-DAG that represents a subcomponents where it orchestrates any other component you combine them as a sub-pipelines. And these two, that all needs a driver to kind of represents what are the runtime configuration it need to take and produce an execution ID. So the MMD, metadata window, what kind of metadata is being stored as this, DAG. And so when we actually look into how each, DAG is being implemented, when we look at first is the root DAG, which is just the first task of a pipeline and generate the root execution ID. All you need to take is the runtime config when you compile the pipelines. And what its job is just to generate an execution ID as an output. So other sub-DAG and the dependency task will be able to take that execution ID and produce metadata based on that ID order. And the sub-DAG driver basically is the first task of a sub-pipelines. It needs the following inputs, right? It needs the DAG execution ID, which it could get from the parent DAG's execution ID. And we will need to take the list of components and tasks you need to produce, right, as part of these sub-pipelines. And once the sub-pipeline is done, it's going to generate an execution IDs for the task in the sub-DAG and any executor inputs for all the components and tasks need to be run in that pipelines. And if this will be a caching mechanism, if the this sub-DAG is already being cached, the condition could also match based on if the cache is hit, it will be able to skip the whole sub-DAG and not have to rerun all those components that already produced in the previous sub-pipelines. And there's a second level of the driver. So once you get into a sub-pipeline, you will have each individual component need to run. And all those individual components will leverage the concept of a container drivers, where the container driver is basically to create an execution ID and links to its parent DAG. And then the execution ID basically just able to retrieve parameters and artifact information from MMD to either calculate or substitute input parameters and generate. If you have path spec change, you need to be in the Argo case, you will generate a path spec path for your executor and publisher to execute in the next steps. And as part of this, you're also able to calculate a cache decision for this particular task. If the cache is hit, you're also able to skip the whole execution and then just use the cache information as the output and store to MMD. And whenever the cache is not hit and we actually need to execute this task, this is when the executor and the publisher mechanism has to come in. So when executor and publisher part is created, it basically just take the following inputs, right? Because the container driver produced in the execution ID, the executor inputs, and then the cache decision to the executor. And the executor also takes in the run ID from the pipeline run itself, and the pipeline names, and all the base components back from the pipelines. And combine those two information, you'll be able to produce the path specs of the necessary environments for the executor to run. And then because the publisher need to push all those artifacts and parameter back to MMD, it also needs the following information: the MMD server address and the MMD server parts as part of the executor and publisher part itself. So whenever the executor is run, the init container in the right hand side, it shows the init container basically just pass in the KFP entry point that is like the binary that wraps the publisher code on top of the executor. Basically just run over the command to download the artifacts. Once the artifact is ready, because the parameter is already replaced by the drivers, it just runs the executor command from there. And once the executor is finished, then you're able to upload the artifacts to your object storage, and then publish all the metadata you produce for that task to MMD. So this way is very all the metadata and artifacts done within the Kubeflow pipeline implementation. So we don't have to rely any feature from Argo or Tekton in this new design. Since we already talked about how the driver and publisher mechanism is working in terms of the Argos, now I want to dive in a little bit history and why we want to use Tekton and what the benefits of using Tektons. So Tekton is a pipeline project provide Kubernetes style resource for declaring CI/CD style pipelines. It has similar mechanism like Argo. It has pipeline run to represent a whole pipeline flows. A task run, it represents multiple steps to run a task inside one pod. And they also have a capability to create a custom run, which it basically connect to a controller where you can actually run all of your workflow inside that controller, or use that controller to distribute your workflow to like active worker pods. And with this controller mechanism is very powerful because we see in other let's say more distributed workflows and training platform like Spark and Ray, they usually have like active worker that is ready ready to take up a lot of batch jobs. And having active worker already reduce the bottleneck of creating a new pod just to run a very simple let's say a bash script or a driver script in this case. And one of the other reasons we want to use Tektons with IBM is because of we are leveraging OpenShift for all our enterprise users. And one of the key features from OpenShift is OpenShift pipelines. So a little bit background. So OpenShift Container Platform is a industry leader enterprise Kubernetes platform, and it brings out out-of-the-box many features for developers, including CI/CD. The CI/CD capabilities on OpenShift is OpenShift pipelines. OpenShift pipeline is based on the Tekton projects, which it offers a very native integration with the OpenShift platform to provide a very smooth experience for the developers and allow our enterprise users already using OpenShift pipelines in their production environment already. And in addition, we work closely with the Red Hat teams to provide security patch to Tekton OpenShift pipelines. So OpenShift pipeline is certified by Red Hat for OpenShift, and also it has enterprise version available on OpenShift out of the box. And because of all these additional features we get from just working with the OpenShift and Tekton community, we want to run a very secure pipeline, even though it's a machine learning pipeline. If we could leverage Kubeflow pipeline mechanism, but just run all its parts, all its workflow logic on top of Tekton itself, it will really help us leverage all the security features when we actually run our enterprise workload on OpenShift. And this is why we are very encouraged to run any secure ML pipelines using OpenShift pipeline platforms. So now I kind of really summarize on a high level some of the benefits of running OpenShift, running Tekton on OpenShift and OpenShift pipelines for our enterprise user. And from now on, I'm going to describe a little bit on how we actually integrate Tekton backend itself into Kubeflow pipeline v2s. So in the early days of Kubeflow pipeline v2s, it is still very specific on using the Argo clients for taking its Argo spec and then using the Argo clients to run all the pipeline is produced, even within the backend microservice itself. And this is what we see an opportunity we need to introduce a abstracted layers within the Kubeflow pipeline services. So in these abstracted layers, it actually produce an abstracted interface. It includes three major parts. One is the compiler is responsible to compile your intermediate representations from the UI into the actual Argo or Tekton spec under the hood. And it also, produce a, what we call a client execution spec to kind of abstract the interface for your underneath orchestration engine clients for creating all those actions for create, get, patch, delete, and representing the spec you're going to store when you actually run those actions. And this, abstracted interface currently is actually embedded within all the Kubeflow pipeline microservices because I think at this moment for Kubeflow pipeline 2.0, the IR specs still haven't fully implemented. There's still a missing feature for status IR. So when we actually retrieve status, there's still certain dependencies that we need, the orchestration engines to give us the status and then store them into the database itself. So this is why we still have multiple places that actually need to utilize this abstracted interface. But in the future, I think we are aiming to just have the API server to have this interface itself, and any other microservice to just utilize the API server to communicate with the underhood orchestration engines. And with these abstraction layers, we're now able to just plug in any backends into this abstracted interface. And at first, we actually just put in all the feature we need for Tekton. And once we put in all the function that we need to run using the Tekton clients, now we need to actually compile the Tekton, compile the pipeline in terms of the Tekton runtime. Because Tekton actually structure the pipeline workflow itself slightly different from Argo, so we actually have to slightly alter our driver designs to make it be more optimized and performance when we run it on top of Tekton. So when we're actually running the drivers, unlike the current Kubeflow pipeline 2.0, I think in the design dot itself, there's a plan to actually run on Argo HTTP templates. But we on the Tekton side, we actually already implement a way that able to run the drivers without creating new pods. And on Tekton, because we are having the capability to run a custom run, we actually create a custom run that use a control that we have produced to actually just run all the Kubeflow pipeline drivers. So this actually enable us to have the driver to store all the information for MLMD and able to produce what we call an executed input because Tekton doesn't really have the pod spec path. That's a feature specific Argos. So we have to alter that feature a little bit as well for Tekton. And once those two features are modified, then we're able to run the driver code itself pretty much out of the box on top of the controller. So this way we don't have to create new pods to do all the driver logic for storing information MLD and replacing parameters for our pod spec. And just some other minor difference when we actually compile into Tekton. So it's very similar to how Argo is being done, but it's just that all the dependencies we actually have to connect with the Tekton run after that. It just create a dependency tree for all the parent DAG and all the dependencies. So because Tekton does have a different way to represent that, it doesn't really have a concept of that. It just create another pipeline representation. So we do have to alter that design a little bit, and for the when, it's just a different name of the when expression. Tekton when it's just a basic string mapping. So we just have to make sure the condition result we produce from the subdat is just a string mapping when we decide whether or not the cache is hit and skip for the executor and publisher steps. Um, and with the leverage of the custom task controllers, even though it's run on a controller itself, we're still able to produce all the necessary outputs like the execution ID, executor input, and cache decisions as a custom resource that basically just represents like how you run stuff in the pod, but it's just very basic custom resource on Tekton, and that is very efficient way to just run a piece of code without creating a whole pod to containerize code that is very repetitive. And from a very high levels, so because we actually leverage custom task controllers to run our driver, and in the future we're also going to use those for our publishers. You could see like within a whole pipelines, when we actually run Kubeflow pipeline on Tekton 2.0, if the cache is not hit, you have like two tasks in this pipeline. We only need to create two pods. Whereas I think in the algo designs, every single driver is still need to be run as a pod. So you have a lot of additional pods need to be run with the algo designs. And although this design is very doing well with our current Tekton implementation, we do see like Tekton does have a bottlenecks when you create a lot of CR. Because even in this case, we're only producing two pods, but we have at least like 6 to 8 CR just to run a two task pipelines. And this is very not optimal when we actually run in a large scale from Kubernetes. This is why we're actually doing a new design for this, where we actually just going to create a very complex and advanced custom task controller that handles both the drivers logics, right, from Kubeflow pipeline, and also all the Tekton's task run, how it kind of take the condition, how it actually produce the pod specs, all in our single controller. So this way we are able to reduce the number of custom resource we have on Tektons by half. So in this case, we could actually reduce let's say in this case we have like, if we have no subDAG, we will only need the root DAG driver, the root DAG publisher, and then just two main advanced task run CR. So that is just like 4 CR, and then at most you will only have 2 pods that running the actual executions. So this is very optimal design that we see that could run on Tektons. So this is what we actually want to approach in the future designs when we make Tekton a little bit more optimal to run on Kubeflow pipelines. And with this, I want to go ahead and demo some of the capability when you run Kubeflow pipeline on top of Tektons. So with this demo, I just want to go over the high levels. With Kubeflow pipeline 2.0, right? Because we're able to share the pipeline spec in intermediate representations. All the SDK and UI image, we are just sharing the same image. There's no change on that at all. And the only difference is that currently we have to modify like 3 different backend microservers to just add the Tekton module, so it could get the Tekton status, trigger Tekton run, and compiles the Tekton pipeline itself. And there's a few extra custom controller that we have deployed for extending the Tekton pipelines, so it could actually run optimal tasks when we run all the drivers to store metadata on top of MMD for Kubeflow pipelines. And last importantly, one of the cool feature from Tekton is that like all the pipeline in Tekton technically could run on istio cycle injections. So if you want that extra layer of security protection, you could also run with istio cycle injection with all the Tekton pipelines. So I do have a backup videos, but in this case, I want to present it live for the demo. So give me 1 second. Let me make it larger. So over here, I have the deployment of Kubeflow 1.8 that run on IBM Cloud. And this is actually backed by the Tekton backend. So from just the UI perspective, you basically see the same UI because you haven't changed the image at all. So you could able to utilize I did log in. Give me 1 second. So we're going to use the same UI over here, and you will see like the same information, just like how you run, Kubeflow Pipeline 2.0 with Argos. And you're able to basically just drag the UIs and then see what kind of information they produce, and the pipeline spec is the same, intermediate representation between both backends. And with that, I could show you some of the runs I had before. So when we have no cache, when we run, let's say the data passing example without any cache, it takes you about 1.5 minutes. But when we actually run the second time with a cache, it's actually less than 5 seconds. So I could actually just rerun this so you could see how fast it could run with the cache. And because behind the scenes, right, when we actually do the caching without creating any Kubernetes pods, we will not have the bottleneck on having to create a new pod on Kubernetes, which a new pod in Kubernetes, as you're aware, it has to construct network connection on the pod and establish all the resource. That usually takes about at least 3 to 4 seconds, right, per pod. So if we could able to eliminate that from both the DAG level and the container levels, that actually really able to help us boost the performance significantly. So you could see, it cached extremely fast, and you could see all this, result is from the cache steps. And, all those, artifacts you could see is basically being stored over here. So I could also show you on the backend itself, there will be no path being created for this run. Although you were able to see what we call the custom run. That is the actual task in the Tekton itself. We could see there are 4 driver tasks that is being executed for this pipeline. Because they are running in a controller itself, it's an active controller. So we could able to handle all those requests extremely fast, less than a second. And you could able to see this pipeline is actually being run, and without creating any new pods. And I think maybe the last thing I want to mention is like you should be able to see with one of our previous runs that actually need to run with actual pods. It has like 3 different containers. I could show you like what are those containers over here. So in the Tekton case, because Tekton by design, it doesn't have the init container. So when we actually need to pass the publisher, what we call, I think, the Kubeflow pipeline launcher, it has to run as a steps just to pass the launcher to the main container itself. And then the main container we're able to run is workloads with just 2 container in this case. And because we were running with istio sidecar injections, you could also there would be another istio sidecar proxies just for an extra layer of protection. But this option could be opt out, so you could actually opt out istio sidecar injection, and you could run the pipeline regularly, because the istio sidecar injection is basically just provide extra layer for you to authenticate and prevent other parts to SSH into your workflows. So that kind of summarizes the good capabilities from Tekton. I want to go over what are the next steps we want to go forward from now on. So we do see we're able to integrate Kubeflow Pipeline 2.0 using Tekton, but we still see few gaps when we're using Kubeflow Pipeline 2.0. I think one of the most important thing is like not all the feature from Kubeflow Pipeline V1 is implemented in V2 yet, especially on the pod spec. As some of the feedback we actually just got recently from our research team is that in V2 there's no capability to specify, let's say, pod level annotation and label, so it's difficult for them to specify like let's say what kind of GPU you want to use on a particular cloud provider platform. So we would like to contribute those features into KFP community as well to make it fully feature complete for V2. Secondly is we want to help community to also implement the status IR. So because right now in 2.0 we're still missing publisher to update the DAG information and the pipeline status in MMD. So it's still using a kind of like a V1 way where the persistent agent has to go into the pipeline status and read and understand what that status is and push that back into the KFP database. So that is not really optimal. We want to have everything just getting from MMD. So I think that is something we want to moving forward. And once we have all those features ready, we would do like to contribute Tekton backend package to KFP, because once those two features ready, we do see we might able to reduce the number of code change and disruption of like the Tekton backend package, maybe down to at most one microservice. And I think at that time, I think it would be a good time for us, to contribute, the Tekton backend back to the upstream communities, because the whole point when we started the KFP Tekton repo is because we are doing a lot of experimental stuff to see how Tekton able to integrate with Kubeflow pipeline. And with the V1 version, there's a tons of code changes. This is why like the repo has been, maintained in this way for a long time. And with KFP 2.0, we finally see a way we're able to contribute back our development for Tekton back to upstream Kubeflow pipelines. And you want to try out Kubeflow pipeline V2 and Kubeflow pipeline V2 on Kubeflow 1.8, feel free to go to the below links. We do have the all the code hosted in our GitHubs. So that is kind of like the end of this presentation. Any questions from the audience?
Okay, anyone else have questions too? So we can just pass the microphone around? Of course. We do have one question. Hold on just a second.
So the most interesting feature of the on Tekton, KFP on Tekton has always been this bin packing idea where you don't end up with one pod per step. What pods are you able to bin pack? Like, is it only the Python ones? Because I assume if it's a component that's like an image spec, you probably can't bin pack that, because that doesn't obviously make a lot of sense. So what kinds of ones do you do? And is it only if they're right beside each other, or is it, do you leave the pod running and then wait and like if there's like a Python step and then a normal step, a component step and then a Python step again, do you bin pack those two that were not adjacent to each other and things like that?
So I think right now, if let's say you have Python, so whenever the workflow that user have defined, we're technically not packing all those into multiple steps inside a pod. We just separate into different pods for those user defined containers. I think the only thing we kind of like group them together is in Kubeflow Pipeline V2, we do have this new concept of driver and publishers. Those are additional steps you have to run to get information from MMD, right? To get all the parameters and push all the metadata back to MMD once you are done. So those steps, because those are very repetitive and those are defined by Kubeflow Pipeline itself, we're able to like push all those tasks into a centralized controller. So because it is always active, so we don't have to create additional pod to just run those repetitive driver and publisher tasks. Does that answer your questions?
Yeah, I mean it does. So
yeah.
Yes, that answers his question. Anyone else have a question? No? Well, Tommy, I don't think there's any other questions, so thank you so much for your time this afternoon, and we look forward to seeing your contributions in the future.
Hey, thank you very much. Have a nice day.
Thank you.